This topic is all about heat transfer. Heat transfer is a process of transfer of heat from high temperature reservoir to low temperature reservoir. In terms of thermodynamics, heat transfer is the movement of heat across the boundary of the system due to the temperature difference between the system and the surroundings. Heat transfer is the transfer of heat is normally from high temperature object to lower temperature object. Heat transfer changes the internal energy of both systems involved according to the first law of thermodynamics. There are three types of heat transfer: the conduction, convection, and radiation. In this figure, the conduction is the transfer of heat from one substance to another by direct contact. The radiation is the energy that is radiated or transmitted in the form of rays, or wave, or particles. The three types of heat transfer has purpose in our daily lives. In conduction, the transfer of heat is through solid material. For example, touching a stove and being burned. Conduction is usually used for electrical purposes. In convection, the heat transfer is through liquid and gases. For example, hot air rising, cooling, and falling. It is usually used in car engines. In radiation, the heat transfer is through electromagnetic waves. For example, the sun, and the heat coming from the fire from far away. Its purpose is for the use of X-ray and in our cellular device. Let's review a little. Temperature is a measure of hotness and coldness. The three units common used in temperature are Celsius, Fahrenheit, and Kelvin. These are the formulas of converting Celsius to Fahrenheit, Fahrenheit to Celsius, and Celsius to Kelvin. Why is heat transfer important? It is basically heat transfer plays vital role in everyone's life. Well, if you think that heat transfer is a little bit easy, well, it's not. Sometimes it is complicated. Like in phase change, there is a heat when the ice melt. There is also a heat when there's a steam. There's also a heat when there's a water. Every matter has a heat. Phase change. Phase change is a change from one state, solid or liquid or gas, to another without change in chemical composition. For example, liquid to solid, liquefaction, gas to liquid, condensation, liquid to gas, evaporation, and many more. In this figure, it explains the phase change in graphical method. In this solid form, which is ice, its temperature is lower than its melting point, which is 0. There will be a specific heat from its temperature to meet its melting point, which is 0. After meeting its boiling point, there will be a latent heat of fusion that will make the ice into water. And in liquid form, water, there will be a specific heat from 0 degrees, and it will raise its temperature to its boiling point, which is 100 degrees. And after meeting its boiling point, there will be a latent heat of vaporization that will make water into steam. And after making water into steam, the process will go backwards, or the steam will raise its temperature into its highest point. Specific heat is the heat required to raise the temperature of the unit mass of a given substance by a given amount. The specific heat formula is mc delta T, m as the mass, c as the specific heat constant, and delta T as the Final temperature minus initial temperature. The 500 gram cube of lead is heated from 25 degrees Celsius to 75 degrees Celsius. How much energy was required to heat the lead? The specific heat of lead is 0.129 joule per gram per Celsius. The mass is 500 grams. The specific heat of lead is 0.129 joule per gram per Celsius, and the delta T, which is T final minus T initial, is equal to 75 degrees Celsius minus 25 degrees Celsius, which is equal to 50 degrees Celsius. The formula is mc delta T, which is 500 grams times 0.129 joule per gram per Celsius times 50 degrees Celsius is equals to the heat, which is 3225 joules. The amount of heat energy released or absorbed when solid changing to liquid and atmospheric pressure at its melting point is known as the latent heat of fusion. The latent heat of vaporization is a physical property of substance. It is defined as the heat required to change 1 mole of liquid at its boiling point under standard atmospheric pressure. The formula of latent heat of fusion or latent heat of vaporization is equals to MLF or MLV. M as the mass, LF as the latent heat of fusion, and LV as the latent heat of vaporization. Calculate the amount of heat added to 1 gram gold to change phase from solid to liquid. The heat of fusion for gold is 64.5 times 10 raised to 3 joule per kilogram. The mass is 1 gram, which is 1 times 10 raised to negative 3 kilogram. The heat of fusion is 64.5 times 10 raised to 3 joule per kilogram. The formula is MLF. 1 times 10 raised to negative 3 times 64.5 times 10 raised to 3 joule per kilogram is equals to 64.5 joules. Gas is a substance or matter in a state in which it will expand freely to fill the wall of a container, having no fixed shape unlike solid or no fixed volume unlike liquid. Gas is a very important part of our daily life. Along with the heat, gas contribute large in factory engines, trains, motor, and many more. The ideal gas law. The gas laws were developed at the end of 18th century when scientists began to realize that the relationship between pressure, volume, and temperature of a sample of gas could be obtained with approximation for all gases. These are the formula for gas law. A 500 ml can of gas is at pressure of 20 kPa. If the can is run over by a garbage truck and flattened to a volume of 10 ml, what is the pressure in kPa assuming the can doesn't leak? Since the temperature is constant, it is a Voigt's law. Pressure 1 times volume 1 is equal to pressure 2 times volume 2, which is 20 times 500 times P2 is equals to 10. Then 20 times 500 is 10,000 divided by 10. Then the pressure is equals to 1000 kPa. What will be the volume of a gas sample at 355 Kelvin if its volume at 273 Kelvin is 8.57 liter? Since its pressure is constant, it is Charles' law. Volume 1 over temperature 1 is equal to volume 2 over temperature 2, and volume 2 is equal to volume 1 times T2 over T1, and 8.57 liter times 355 Kelvin over 273 Kelvin, volume is equal to 11.1 liter. Gas pressure is 765 torr at 20 degrees Celsius. At what temperature will the pressure be 560 torr? Givens are pressure 1 at 765 torr, temperature 1 as 23, plus 273, which is 296 Kelvin. Pressure 2 is 562 and temperature 2 is unknown. Since constant volume, it is Gay-Lussac law. It is equals to V1 over T1 equals P2 over T2. Temperature 2 is equals to temperature 1 times pressure 2 over pressure 1. And it is 560 torr times 296 Kelvin over 765 torr. And it is 217 Kelvin, which is also negative 56 degrees Celsius.
Thank you.